Hey guys, today we're combining 8.1 and 8.2 to look at multiplication properties of exponents. Alright, we are in luck today with our video. My cat Queenie came to co-teach with me, as you can see. Say hi, Queenie! Anyway, we're shifting gears, we're looking at exponents. So we're going to look at a few properties first, and then we'll go into some examples. So the first property we're going to look at is the product of powers property. And this tells us that if we multiply powers having the same base, we need to add the exponents. So in general, if we have two terms that have the same base, so in this case our base is a, and we're multiplying them, what we need to do is add the exponents. So this will become a to the m plus n. So we took the same base, a, and we added the exponents. So for example, if we had 3 squared times 3 to the third. What we would do is we'd keep the same base. They both have 3, so we'd write 3. And then we'd add their exponents, so 2 plus 3. And then 2 plus 3 is just 5. So that's our first property. The next property we have is a power of a power property. So lots of powers. This tells us that to find a power of a power, we have to multiply the exponents. So if we have some base, a, with an exponent of m, and that's in parentheses being raised to another exponent n, what we can do is we'll write the same base, but we'll just multiply our exponents. So we'll have a to the m times n. So for example, if we have 2 squared to the fifth. Well, since we have 2 squared inside our parentheses, we'll want to multiply our exponents. So we'll keep our base 2, but then we'll multiply our exponents. 2 times 5. So this would be 2 to the 10th. The next property we have is the power of product property. And this tells us that to find the power of a product, we have to find the power of each factor and then multiply. So when it says each factor, it's talking about each piece that's inside the parentheses. So inside our parentheses, we have a times b. So our one factor would be a, and the next factor would be b. And so what this tells us is we have to take our exponent, and we need to make sure we distribute it to both of our factors. So we distribute it to a, and we distribute it to b. So this would become a to the m times b to the m. So for example, if we had 10x to the third squared. So on the inside, we have 10x to the third. It's important to remember that this 10 in front of the x implies that we're multiplying it. So that means we have two factors. We have 10 and we have x to the third. So we need to make sure that we distribute this 2 to the 10 and to the x to the third. So this would become 10 squared times x to the third squared. And so now all we have to do, since we have the squared on the outside of a parentheses, we need to make sure we multiply by 3. So we have 10 squared times x to the 6th. Our final thing that we're going to look at before we look at some more examples is the 0 and negative exponents. So anything raised to the 0 power is going to be 1. Anything at all, if we raise it to the 0 power, it's going to be 1. So for example, 10 to the 0, that would be 1. Pi to the 0, that would also be 1. Banana to the 0 would be 1. So as you can see, literally anything, if we take it to the 0, it's going to be 1. Now when it comes to negative exponents, so if we have a base with a negative exponent, what we need to do is flip our fraction and make the exponent positive. So for example, 10 to the negative 1. Whenever we don't have a denominator, this implies that we have over 1. So what we do is we flip our fraction and we make our exponent positive. So this would become 1 over 10 to the positive 1, which we could just write as 1 over 10. For b, we have a to the negative third. So again, this implies that there's a 1 in the denominator. So we need to flip our fraction and make our exponent positive. Flip our fraction 1 over a and make our exponent positive. So positive 3. So it becomes 1 over a to the third. For c, we have 1 over n to the negative second. So this time our base is in the denominator, but the same rule is going to apply. We're just going to flip our fraction and make our exponent positive. So 1 over n to the negative second, if we flip that, we get n, we make our exponent positive, over 1. But anything over 1 is just that thing, so I'm just going to write it as n squared. Okay, so let's look at some examples using these properties. So for the first example, we're asked to use the product property to simplify the expression. So the product property tells us that if we're multiplying two things with the same base, we add their exponents. When we have 4, this technically implies that we have a 1 in the exponent for both of them. So if we're multiplying 4 times 4, that means we have to add their exponents. So 1 plus 1 would be 2. So this would be 4 squared. And that should make some sense, because we know that 4 times 4 is just 16. But we also know that 4 squared is 16. So it makes sense that we get 4 squared. For b, we have m to the third times n squared times n to the fifth. So we need to add our exponents but keep the same base. So these all have the same base, so we'll keep our m, but then we'll add our exponents. So we have 3 plus 2 plus 5. 3 plus 2 is 5, plus 5 would be 10. So we get m to the 10th. For part c, we have a to the 10th times a squared. So again, we'll keep our same base, which is a, and then we'll just add our exponents. So 10 plus 2. 10 plus 2 would be 12, so we get a to the 12th. Go ahead and try this last one on your own. So we have y times y times y times y. Remember, in each of the exponents of all of these y's, we have 1. So we'll do the same thing. We'll keep our base, which is y, and then we'll add all of our exponents. So we have 1 plus 1 plus 1 plus 1. So we get y to the 4th. In the next example, we're asked to use the power of power property to simplify the expression. So in all of these examples, we have parentheses. So that means we're going to need to distribute our outside exponent to our inside factors. So we have 3 squared to the 4th. Well, in this case, we only have one term inside the parentheses, and that's 3 squared. So all we'll have to do is multiply our exponents. So we'll have 3 to the 2 times 4, which would just be 3 to the 8th. For part b, we have 2a to the 3rd squared. So in this case, remember 2 is being multiplied, so that means we have 2 factors inside our parentheses. So we need to distribute our squared to the 2 and to the a to the 3rd. So we'll have 2 squared times a to the 3 times 2. Well, 2 squared is just 2 times 2, which would be 4. And then a to the 3 times 2, which is 6. For c, we have negative 3 squared to the 4th. This one's just a little bit tricky because we need to remember what it means when something has a negative in front of it. When something has a negative, that implies that we have negative 1 times our number. So for this one, we actually have 2 terms. We have negative 1 and 3 squared. So we need to distribute our 4 to the negative 1 and to the 3 squared. So we'll get negative 1 to the 4th times 3 to the 2 times 4. I'm going to take this a little bit off to the side just for a second. So negative 1 to the 4th, remember that just means we're multiplying negative 1 by itself 4 times. So we have negative 1 times negative 1 times negative 1 times negative 1. Now negative 1 times negative 1 is just positive 1. So we'll get positive 1 for this part and for this part. We have positive 1 times positive 1. So we just get positive 1. So long story short, our negative 1 goes away since it ended up being positive 1. And we just get 3 to the 2 times 4, which would be 3 to the 8th. Finally, we have 4x squared. So remember, 4 is being multiplied. So that means we have 2 terms inside our parentheses. So we'll have to distribute our 2 to the 4 and to the x. So we'll get 4 squared times x squared. But 4 squared is just 16, so we can write this as 16x squared.